Hello and welcome to the physics tutorial for GCSE Physics topic P2 electricity. This covers part 2 mains electricity. First of all, you need to know the difference between direct current and alternating current, or AC/DC. Direct current, or DC, is when the current is always flowing going in the same direction, like a battery or a cell, as you can see here. Alternating current is when the current constantly changes direction. And that's the way that the UK mains electricity works. That's alternating current. UK mains electricity is 230 volts at a frequency of 50 Hertz. You need to know what the 3-pin plug looks like for the UK. Inside, there are wires covered in plastic of different colours, so they're easy to identify. The live wire is the brown wire, and that provides 230 volts from the mains into the device. The neutral wire is the blue wire, and that completes the circuit, so normally has a voltage of 0. The earth wire is yellow and green, and that's for safety. So if there's a fault, it provides a safe path for the current to flow into the ground. So normally, if everything's fine, then nothing will pass through it. The outer insulation is plastic, obviously an insulator, and there's a grip to keep the wires in place. There's also a fuse that's got a wire inside that melts if the current is too high. Most metallic devices that you plug in have an earth wire connected directly to the ground inside, as shown here. This prevents you getting an electric shock if there was a fault and you touch the device. The national grid provides electricity to all of the UK. It's made up of cables, pylon towers and transformers. When electricity leaves power stations, it goes into a step-up transformer. That increases the voltage to around 400,000 volts. This then goes into cables and around the national grid. This is at a high voltage and low current. Now, if the current was too high, the cables would actually just get too hot and energy would be lost as heat energy into the surroundings. So instead, it's more efficient to have a high voltage and low current. When electricity reaches the houses, it enters a step-down transformer to lower the voltage to a safer voltage of 230 volts. Transformers are made up of 2 coils, the primary coil, which is the first one, and the secondary coil, and then also an iron core. Step-up transformers, they increase the voltage. There's more turns of wire on the secondary coil than there are on the primary coil. This also decreases the current. Step-down transformers, as shown here, they decrease the voltage. So there's more turns on the primary coil than there is on the secondary coil, and this increases the current. You also need to know about power. So there's 2 calculations. Energy transferred is power times time, and power is also potential difference times by current. Most appliances that you plug in have a power rating. That's the maximum amount of power that can safely go into the appliance. So it's a maximum amount of energy transferred per second. And in general, the lower that power rating, the cheaper it is to run. If you pause the tutorial and try these questions now. In the UK, the voltage of the main supply is 230 volts with 50 Hertz frequency. The yellow and green wire is an earth wire. And the role of step-up transformers is to increase the voltage and decrease the current. So energy is not lost as heat into the surroundings. It's a more efficient way to carry electricity through the national grid. In summary, we've looked at mains electricity. Thank you.